So before we get started, we're going to look at problem number 13 from 1.5. Problem number 13. So we want to find the ordered triplet that makes these three equations true. Now, here, x, y, or z, all of them are good options to eliminate out, be the first variable to eliminate. I'm going to pick z. No real reason, I'm just picking z. And I'll pick the top equation as my eliminator equation. So I'll write the other two out. So x plus y minus z equals 0. And our other one is 3x plus 2y minus 3z equals -1. Now, since our eliminator equation, that's not a 0, that is a 2. And the equation on the left both have one z. We don't have to do anything to them to get the z's to match up. And at this point here, we're going to subtract, because negative z minus negative z, -1 minus -1, is indeed 0. X minus x is also 0. Y minus 3y is going to be -2y. Z minus z, negative z, or negative z minus negative z is still 0. 0 minus 2 is -2. Since we only have one variable left, we'll divide both sides by -2 and get that y is equal to -1. So we do have a specific value for y. Now, if we do the same thing, we eliminate z out of our other equation. We've got to take this eliminator equation and multiply the whole thing by 3. So I said we have 3x plus 9y minus 3z is equal to 6. And again, just like with the other equation, we're going to subtract, because -3z minus -3z would be 0. Incidentally, 3x minus 3x is also 0. 2y minus 9y is -7y. And this is equal to, let's see here. Nope. Yeah. I have that wrong. It should be +1. Divide both sides by -7, and y is 1. So when we did this here, it ended up eliminating everything out, telling us y is 1 in both cases, yes? So what I want to do is, what I'm going to do, I'm going to erase all this here. Again. Third time's the charm. There we go. If I look at the three equations, I'm just going to put 1 in for each of these y's and see what happens. So if we look at the top equation, we'd have x plus 3 times 1 minus z is equal to 2. Okay. I'm going to get x and y, or x and z by themselves. Minus x minus z is equal to -1. Okay. There's one of the equations. This will make sense in a minute. I'm going to take the second equation and plug in the fact that y is 1. And when I do it for the middle equation, we get x plus 1 minus z is equal to 0. Again, get x and z by themselves, and it tells me that x minus z is equal to -1, yes? Wait a minute, aren't those both the same equation? Let's see what happens in the third one. 3x plus 2 times 1 minus 3z equals -1. Well, 2 times 1 is plus 2. At this point here, we can minus 2, telling us ax minus 3z is equal to -3. Is that the same equation as the other two? Now this one's, everything's been multiplied by what? 3, yes? So if I divide everything by 3, it'll tell me that x minus z is equal to, those are all the same equation, yes? Infinitely many solutions. Yeah, if you eliminate y out first, you'll get 0 equals 0. You're done. 13. 13 is infinitely many. So depending on which variable you eliminate first will change how it looks. Because since we eliminated x and z, and since they depend on each other for a value, they're going to eliminate each other out. If we eliminated y first, x and z would have also eliminated each other, and we would have gotten a true statement. Yep, you can put it on my desk.
I have a question. So half of one, because I don't know where I messed up, and then I don't know which.
Which one? From 1, 5? Look at number 5. I'm going to snag that back. Let you have that. We'll look at 5 and then we'll go on and get started. So these here are our 3 equations. Now we need to pick x, y, or z to eliminate one of the variables out of the other 2. And looking at this here, x works because I can multiply the middle one by 2 to get to the top and multiply it by 5 to get to the bottom. Y, we can use the one on top, multiply it by 6 to match up with the middle, multiply it by 7 to get the bottom. Or z, so I can use the top equation and multiply by 2 to get to the middle. It's already the same as the bottom. So I'm just going to use the middle equation, or the top equation, and eliminate z first. Now for our equation on the left, how I set this up, the z's already line up. They're 1z and 1z. Now the signs are different. That's okay. But we want the number in front of the z, or the variable we want to eliminate, to be the same. So we do indeed have 1z and 1z. Since the signs are opposite, we're going to add. Because negative 1 plus 1, 1 plus negative 1 is indeed 0. So z plus negative z is 0. Now as we add the rest, 5x plus 2x is 7x. 7y plus y is plus 8y. 4 plus 9 is 13. Now at this point here, we do have to do some multiplication because we need the z, our 1z, to become 2z. So we're going to have to multiply this entire equation by 2. 2 times 2x is 4x. 2 times y is plus 2y. 2 times negative z is negative 2z. And 9 times 2 is 18. Now at this point here, we can put it underneath our other equation. 4x plus 2y minus 2z equals 18. Now again, at this point, we want the z's to eliminate. 2z plus negative 2z. 2 plus negative 2 is indeed 0. Since adding those two gets z's to cancel, we're going to add the rest. Negative x plus 4x is 3x. 6y plus 2y is going to be plus 8y. Negative 17 plus 18 is 1. Now at this point here, the y's already match up. They're both 8y. So we can put those over the top of each other and eliminate our y's. Now, since the signs are the same, we're going to subtract because 8y minus 8y, 8 minus 8 is indeed 0. 3x minus 7x, 3 minus 7 is going to be negative 4x. 1 minus 13 is going to be negative 12. Divide both sides by negative 4, and we get x is equal to 3. 3x plus 8y. At this point here, we're going to solve backwards. So 3x plus 8y is equal to 1. Well, our 3 times 3 is 9. Minus 9, telling us 8y is equal to negative 8. Divide by 8, telling us y is negative 1. Yeah. 2x plus y minus z is equal to 9. Make sure I get this right. So we'd have 2 times 3 plus negative 1 minus z equals 9. 2 times 3 is 6. Or plus negative 1 is just going to be minus 1 minus z is 9. 6 minus 1 is 5. To get z by itself, we would minus 5 from both sides, telling us negative z is equal to 4. 2x plus y minus 1. Divide both sides by negative 1. Telling us z is negative 4. Yep. So the answer is 3, negative 1, negative 4.
That's on 1.5.
Yep. Number 5. Questions on this here? All right.
And then one last question I can jump to tomorrow. Which is our eliminator problem on, like, what will we use as the eliminator on 11?
11. So if we look at that 3x, 6x, 2x, none of those are great. 2z, 4z, 3z, none of those are great. I would go with y because we have 1y, 2y, 1y. So we have 1y for sure that I can turn into the others. Because if one of them just has 1, that's the easiest one to eliminate, or easier one to eliminate out of the other two. Now, what we're looking at today is, first off, is addition and subtraction with matrices, adding and subtracting two matrices. Now we can add and subtract two matrices if the dimensions are the same. If the dimensions are the same, we add the corresponding elements. If the dimensions are different, it is undefined. If the dimensions are different, it is undefined. We cannot add or subtract the matrices. We can only add or subtract matrices if the dimensions are the same. So if we look at this first one here, our first matrix is A2 by 2, yes? The second matrix is a 2 by 2. So since the dimensions are the same, we can add and subtract. And we add and subtract the corresponding elements. So 2's corresponding element is 1, top left, top left. So we would perform the operation in the middle, so we would add. Our next element, negative 1's corresponding element is 2. So we would add those. Then we have 3 and 4. And lastly, we have 0 and we add those. Since the dimensions are the same, we add the corresponding elements and get this here. Questions on this so far? Now, the last thing we need to do is simplify. What is 2 plus 1? Negative 1 plus 2. 3 plus 4. 0 plus negative 2. That's it. That's all we have to do. Questions on this here? Are you ready for the next one? Let's look at the next one. So the first one is a 3 by 2. The second one is a 3 by 2. And the subtraction sign in the middle says we're going to subtract our corresponding elements. So we'd have 2 minus negative 1. Then we'd have negative 3 minus 2. Then we'd have 5 minus 7. Our next one would be 4 minus 8. Then we'd have negative 2 minus negative 5. And lastly, 8 minus 6. Questions on this here? Questions on how we set this up? Well, the last thing we need to do is simplify 2 minus negative 1. Well, negative, negative make a plus, telling us that it is indeed 3. Negative 3 minus 2. Negative 5. 5 minus 7. Negative 2. 4 minus 8. Negative 4. Negative 2 minus negative 5. The negative and negative make a plus, giving us 3. And 8 minus 6. Questions on adding or subtracting so far? We feel good with these here? How about this one here? What would we do first? See if they're the same. Yes, what are the dimensions of the first matrix? 2 by 3. What about the second one? 2 by 2. Are the dimensions the same? No, so can we add or subtract? No, so this here is what? Undefined. If the dimensions are not the exact same, we cannot add or subtract. And it is undefined. We cannot add these two together or subtract them because the dimensions are not the exact same. Because the only way to get them to be the same is to add another column. But once we add another column, that matrix is different. We've changed it. Does that make sense? Yes? Now, a question I always get, because we did these here, we plugged matrices in yesterday and Friday. We kind of went over how to put them in. We can actually type these in. I could define this as A, and this as matrix B, and then we would add them. So to do that, we'd pull the graphing calculator up, say second matrix, go over to edit, and we'll pick A. Now we'll put the dimensions in. A is a 2 by 2, negative 1, 7, 5, 3. second quit, second matrix, over to edit. We'll go down to B. It is also a 2 by 2. 6, -4, -8, 2. And once we get them typed in, we need to recall them. So the name slot lets us recall it. So we'll say A plus second matrix B. And we can verify that because we would add corresponding elements. So we'd have -1 plus 6, 7 plus -4, 5 plus -8, 3 plus 2. Well, -1 plus 6 is 5. 7 plus -4 is 3. 5 plus -8 is -3. And the last one, 3 plus 2, is indeed 5. But I think for the most part, we could do this by hand as fast, if not a little bit quicker, than we could type the whole thing in. Questions on these addition problems or subtraction problems? So 2 minus -3 is the same as 2 plus 3, and 2 plus 3 is 5. 5 minus 0, that's just 5. I have had students ask, do I have to write the step in the middle? Now, if you feel comfortable going from our starting problem to 5, 5, or 2 by 1, that's fine. Sometimes those negatives can sometimes get tricky, but again, the calculator could have done that for us. What's the answer for C? Undefined. We have a 2 by 1 and a 1 by 2. Not possible, it's undefined. Do we need to see another example of addition or subtraction with matrices? Okay. Next thing we'll look at is scalar multiplication. So when working with matrices, a real number is often called a scalar. To multiply a matrix by a scalar, multiply each element in the matrix by that scalar. This process is called scalar multiplication. So let's just look at an example problem. Let's look at this here. What would the scalar we're multiplying this by be? 2, yes? So that means to do scalar multiplication, we're going to multiply every element in this matrix by 2. So that means we're going to have 2 times 3, and 2 times -2. We'll also have 2 times 1, 2 times 5, 2 times 2, and 2 times 0. Scalar multiplication just says we multiply every element in that matrix by that scalar. So here we're multiplying everything by 2. Two times 3, 6. 2 times -2, almost. -4. Then 2 times 1, 2 times 5, 2 times 2, 2 times 0. Now, how you go through simplifying doesn't matter. If you go from top left to bottom left, that's fine. As long as the final answers match, we're good. How do we feel about scalar multiplication? Feel good? Normally I have example after example. This one I have one. Because I think we feel good with this here, yes? So we're going to put the two together. We can have scalar multiplication and addition and subtraction. Because I would say, especially with the calculator, doing a scalar multiplication in the calculator, like the last one we did, it's easier just to do that by hand. We're just multiplying everything by 2. the calculator is going to get a little quicker when what we're multiplying, the scalar we're multiplying it by, isn't a nice number. 7/15. Okay, it's going to take a little bit longer to do those. Here, not too bad. When we start combining them, it can sometimes take a little bit longer to do them by hand. Not that they're harder, it just takes a little more time. Because the first thing we need to do is multiply any scalars first before we do addition or subtraction. So the first thing we want to do is multiply this first matrix by its scalar -3. So we'd have -3 times 5, -3 times 0, -3 times -2, and -3 times 4. Now, since the second matrix does not have a scalar in front of it besides 1, we're not going to do anything with it. It's just going to stay the way it is. At this point here, we can multiply by -3. -3 times 5 is -15. -3 times 0 is 0. -3 times -2 is 6. And -3 times 4 is -12. Now that we've taken care of all of our scalars, now we can just add the two together, yes? So I'm going to write it out. If you don't need to write it out, that's fine. Because we would be adding like elements, so -15 plus -1, 0 plus 7, 6 plus 3, -12 plus 2. Which is really telling us that -15 plus -1 is -16. 0 plus 7 is 7. 3 plus 6, 9, and -12 plus 2 is -10. Yes? That's it. Questions on our scalar multiplication, addition, subtraction? Questions on this here before we move on? We all good? All right, we're going to do one more. I don't think we need to see 5. Give me a number between 0 and 10. Doesn't matter. 8. Okay. Now, I want to change up number 6 just a little bit. You can sneak an 8 right in there because this, not tricky, not a whole lot, but I do want to talk about it. Because with this here, problem number 6, the first matrix having that 4 out in front, we're good because we would just multiply everything by 4. So we're multiplying every element in this matrix by the number 4. Which is fine. There's nothing wrong with that. Now, the second matrix, we have some options. Mainly 2 options. There's 2 things we can multiply this scalar by, or multiply the second scalar as. The first is we just say it's 8. We're going to multiply everything in that second matrix by positive 8. So we have 8 times 9. 8 times 7. That needs to be a bit bigger. 8 times -6. 8 times 5. 8 times 2. And 8 times -3. We'll finish multiplying those scalars, those elements together, and then we can subtract. Yes? That's one of our options. The other option is instead of multiplying it by 8, we can multiply everything by -8 because we have that -8 in front of that matrix, yes? So what we're doing is we're taking the 8 and multiplying it through and the negative. But if we do this, we would not subtract next. We would Yeah, because we took that negative out, it would change it from subtraction to addition. Do we see how that works? So you have two options. So if you want to take that negative with it, not worry about that, multiply it by -8. If you don't want to worry about multiplying by a negative, multiply it by 8 and then subtract. You will get the same answer. So I'll show it here with -8 first. So if we multiply this first one by 4, 4 times 3 is 12, 4 times 5 is 20, 4 times 4 is 16, 4 times 2 is 8, 4 times 0 is 0, 4 times -2 is -8. Our second one, -8 times 9 is going to be -72. -8 times 7 is going to be -56. -8 times -6 is going to be 48. -8 times 5 is -40. -8 times 2 is -16. And -8 times -3 is 24. We good with that there. Now at this point, we're going to add 12 plus -72, 20 plus -56, 16 plus 48, 8 plus -40, 0 plus -16, and lastly -8 plus 24. We're going to be adding these together. Now when we do, 12 plus -72 is going to be -60. 20 plus -56 is going to be -36. 16 plus 48 is going to be 64. 8 plus -40 is -32. 0 plus -16, -16. And -8 plus 24 is going to be -16. Questions on how we got that there? We feel comfortable with this here? I mean, once we get some practice, it might feel a little better, but we kind of understand the process, yes? Now, I would say with some of the bigger ones where we're getting multiple scalars, multiple things we're adding and subtracting, the calculator is going to become a little bit quicker, especially if we're doing multiple problems with the same 3 matrices or same 4 matrices. It will check them out quicker. Now, I did say I would go back and show this again. What I'm going to do is that. You don't have to change it. You can just watch this here. There's an eraser. As if we kept it as +8 instead of -8 and then subtracted. Let's see what changes. Well, this would be 8 times 9, which is +72. 8 times 7 is +56. 8 times -6 is going to be negative -48. 8 times 5 is going to be +40. 8 times 2 is +16. 8 times -3 is -24. And again, we're going to be subtracting, yes? So what do we have now? 12 minus 72. Is that the same as 12 plus -72? Yes. 20 minus 56 plus a negative. Well, that's the same as just saying minus. 16 minus -48. So we'd start off with that minus a negative. Well, a negative and negative make a positive. So we're back where we were. 8 minus 40. 0 minus 16. And then lastly, we would have 8 minus -24. The negative and negative would be plus. And we get the exact same answer. Do we kind of see how that works? It doesn't matter which one we pick, you've got to pick one or the other. But that's it. Incidentally, that is the end of chapter 1. We are done with chapter 1. So tomorrow will be a makeup day. You have the entire class period to work on any missing assignments. I will give you a missing assignment sheet and everything that you are missing. Friday will be a review day. I will give you the review sheet. You have the entire class period to work on. Monday, we will go over the review sheet. Tuesday, Thursday. Tuesday will be part 1 of the test. Wednesday will be part 2. And then there's a good chance we will start chapter 2 on Thursday. We'll see. Friday is homecoming. We're not going to be doing anything Friday.